Hello everyone. The course title is The Future of Manufacturing Business, Role of Additive Manufacturing. So, I'll just give you a brief overview of the course. You might have already seen that in the introduction, what has been uploaded earlier. So, this course will be taught by me and Dr. Chandrasekhar from Wipro 3D. And I would cover mainly the business part of manufacturing, and he will cover more on the technology side of additive manufacturing mainly. And if you look at the course content broadly, we will talk about business models, we are going to talk about technology, we are going to talk about how you actually can reconfigure supply chains. So, my part would be on some of these topics like the manufacturing paradigms, advances in manufacturing and the supply chain management, economics of manufacturing and manufacturing architecture and business models for manufacturing. And if you see maybe as we go along, you would actually realize that I've classified all these topics into three broad themes. One is the background of the future. The second is the technology of the future. And then at the end we will have the future, right? And all these things are mainly for the manufacturing, correct? So, when we talk about background, I will give you different manufacturing paradigms. I am going to talk about the economics of manufacturing, introduction to business models. When I talk about technology, I will actually selected some technologies which may be relevant for the future manufacturing. I may have brief introduction to artificial intelligence, how it is coming in manufacturing, brief introduction to blockchains, how they are actually helping us to reconfiguring supply chains and manufacturing. Some introduction to additive manufacturing, because the bulk of the introduction will be covered, or technical backgrounds will be covered by Dr. Chandrasekhar. And yeah, so this some three broad technologies, right? Maybe I will also have some discussion on the IoT part, so that will be very brief, but mainly these three, right? And when I talk about the future, I will actually look mainly the cases, maybe the successful cases of how the manufacturing is changing with the introduction of these technologies, right? So, this is the portion which is going to be covered by me, and this is the portion which is going to be covered by Dr. Chandrasekhar. And he would be talking more on the materials and the technology side of additive manufacturing. And at the end of the course, we actually have invited one industry speaker who is going to talk about the future of manufacturing radar. So, he would actually show you how these technologies actually integrate, right. So, yeah, so these are some of the cases which will be discussed by Dr. Chandrasekhar. So, you can actually see that in fact one thing which here, if you see this, he's talking about the India's first additive manufactured part in space. It is actually used for the satellite GSAT-19, right. So, he will cover some of these cases, and some of these cases are actually part of Wipro 3D. And I may also touch some portion how additive manufacturing is actually allowing us to matching constrained supply with critical demand during COVID-19, right. So, I will try to bring some used cases from COVID-19, right. Okay, so continue with this. I will now venture into the technical side, right. So, we will start with the very simple question, right. So, what is manufacturing, correct. So, how you define manufacturing. So, I have just taken the definition which is given by CIERP, and that defines manufacturing as a series of interrelated activities and operations involving the design, materials, selection, planning, manufacturing, production, quality assurance, management and marketing. So, if you actually see this definition, it is highly encompassing. It in fact covers more or less all functional areas of management, right. And right from they say procurement to the marketing. So, supply chain, everything is integrated into this definition. So, looking at this definition, it means that we are actually talking about a very large spectra of activities. And just to give you a flavor of how this word actually come, right. So, the origin is in fact Latin, right. So, manus is hand and fatio is to do. So, when we are talking about manufacturing, we are actually talking about maybe the Latin origins, right. So, it is about doing something, right, and maybe doing by hand, right. But I think that is where the technology differs, because more and more automation and digitization is actually coming, right, and we'll discuss as we go along, right. So, with this simple definition, I would ask you so when we talk about manufacturing, so the definition part is over. Then the question here is what is ideal manufacturing, right? Or put it that way, is what actually you should get out of manufacturing, correct? So what are the goals of manufacturing, correct? So if you look at this particular slide, so this is from a very famous science fiction serial, Star Trek: The Next Generation. So some of you might have seen it. So when I was kid, I think it used to be telecasted in DD. So this is the Captain Picard. So one of the actors in that serial, and very often he used to use this particular thing, tea Earl Grey hot, right? And as soon as he says this, within some seconds, the tea will actually come in. It will be Earl Grey. It will be hot, right? And the spaceship in which they are actually have shooted the whole thing was this Enterprise, and this machine is the replicator, correct? And the back end part of replicator, at least what is revealed in this whole science fiction thing, is that it actually can self assemble atoms into food and drink, right? So if I am looking for an ideal manufacturing scenario, the machine actually can convert anything to everything, right? So as soon as I start thinking about something, the machine has the capability to convert maybe any raw material to whatever I am looking for, right? So if you think of maybe Aladdin's lamp, so whatever you wish for will be immediately provided. So can we actually have a manufacturing system of that kind, right? Is it possible to think of that, right? So coming out of science fiction, is it possible to actually have those things in reality, correct? So the science historian James Burke, he has a very interesting quotation that something is going to happen in the next 40 years that will change things probably more than anything else since we left the caves, right? And I think his context was talking about manufacturing. So when we look at, so this is maybe some kind of a blog. The title is How a Machine That Can Make Anything Would Change Everything, right? And the machine which may resemble the Enterprise replicator may be going to come in future, and that is nanofabricators, right? So you may actually see advances in technology to such an extent that the atoms can be reconfigured into different kind of products, right? So that is actually too far into the future. We may not be covering that dimension of manufacturing in this course, but let us see how far we actually can go closer to this, right? So certainly as of now we don't have the technology of nanofabrication, right? We don't have the technology what may be there in replicator, but let us see how far we actually can go close to it, right? So whether we actually can be too far from that. So let us see that how far we actually can go closer to this, right? So as I asked you, like what should be there in manufacturing, what are the goals of manufacturing, right? What is an ideal manufacturing system? So if you just look at the previous examples, the four things which came out very explicitly, right? It should be fast, it should be cheap or economical, it should be better. In fact, we should look for best. For time being, let us confine to better. It means that we are looking for good quality, and it should be diverse, right? So, if instead of Captain Picard, someone else comes and say that I want some other type of tea or white tea, it could be anything else, right? So, replicators should be have the capability or the technology to replicate, to make something which is very diverse, right? But unfortunately, these goals are not in tandem with each other, right? So, these goals may be conflicting, correct? So, it is possible that you actually could have something which is fast, economical, maybe high quality, but may not be diverse, right? So, in fact, when we talk about a typical mass production system, right, like Ford Motors, we'll discuss that in detail. It may be fast, it may be economical, it may have reasonable quality, it may not be the best, but it may not be diverse at all, right? In fact, the Ford Motors used to produce only one type of model, the Model T, at the peak of their mass production system, right? So, these objectives, these goals may be conflicting, right? And then the important question is it possible for technology to actually bring these goals into sync with each other, right? So, there is a very famous quotation given by the economist George Stigler. He got the Nobel Prize in 1982 for a different field altogether. But he has a very interesting paper which he published in 1939, and one of the very famous quotation came out of it is that flexibility is not free, right? So, it actually shows that these two goals may be in conflict with each other, right? So, if I want high flexibility, the things may not be economical, and I think that is the idea which actually comes in mass production systems, where Henry Ford decided to forego flexibility in favor of the cost, right? So, we'll anyhow keep on talking about these things, at least in the first part of the course. Our objective is to actually see how we actually can bring these goals into sync with each other, right? So, I'll now, based on this simple background, I will go into some data. We try to look into the macro picture of where the manufacturing is actually contributing. So, this particular slide, if you see, it talks about the word GDP in the last 2000 years, right? And everything has been adjusted to, so people who have seen how the GDP is normalized. So, everything has been into international dollars in 2011 prices. So, if you actually see that for the initial maybe till 1600 years or 1500 years, there is some kind of the word GDP was more or less constant, right? So, there is not much difference, right? But post 1500 and after maybe 1600, there is a gradual increase, and then there is a really big increase maybe in the 20th century, right? Now, if you look at these numbers, one thing which comes significantly, that the advances in technology during the industrial revolution has significantly impacted the productivity, right? Correct. And most of these advances were actually in the context of manufacturing, right? So, if I put indirectly that manufacturing in fact has changed the way we actually live, right? And in fact, I am just adding something from my side from economics, right? So these we call it the great divergence and great convergence, right. So when I say great divergence, it means that the impact of industrial revolution was not constant across the globe, right. So some countries in fact have advanced significantly compared to the other countries, right. So if you talk about some of the European countries like UK, France, right, Americas like US, so these countries in fact have significantly gained because of the impact of industrial revolution, and so we actually see great divergence, but of post Second World War, or even maybe you can say you can see Japan in fact start matching the American productivity. In fact, they in fact even overtaken that thing. And maybe in 80s we are talking about emerging economies like China, India, Brazil, and then we are talking about the great convergence, right? So is it possible for some of these countries, the emerging economies, to leverage manufacturing, right, and start matching what actually has been observed in the advanced economies, right? So these may be more macro side, right? I will show you some more data on macro. So this source is our word indata.org. So this is taken from tradingeconomics.com, and this is actually from the data originally from Ministry of Statistics and Program Implementation, Government of India, and these are in Indian rupees in billions, right? So we are talking about 6,000 Indian rupees in billions, right? So that is the kind of output which we see the contribution of manufacturing in the Indian GDP, correct? Now I look at a similar number, uh, uh, the similar data for the US economy, and the contribution of manufacturing is more than $2 trillion. This data is maybe first quarter of 2020. So if you look at the Indian size of the Indian economy, which is about 2.7 or 8 trillion dollars, right? So US manufacturing itself is touching that number, right? So when I talked about the great divergence, that is something I was looking at, right? So what we foresee, whether it is possible for Indian manufacturing by using whatever technology to start hitting the numbers like 2.2 or 2.3, right? So that then we actually in fact can achieve the dream target of $5 trillion, right? So if I just start multiplying all these numbers, that is something which we can easily achieve, right? When we can do that, I think that's the different question altogether, right? Now, other thing which has been observed, at least in so the Association of Manufacturing Technology, they have estimated in US 1 million. If you sell $1 million sales of manufacturing goods in US, it normally supports 8 jobs in manufacturing and 6 jobs in the supported domains, right? So it means that $1 million sales will support about 14 jobs. And what they actually have estimated, that none of the other sectors even come closer to it, right? So this becomes really relevant, that the countries actually should emphasize on growth through manufacturing, right? And one more thing which I think you can easily look at these numbers when I talk about the great divergence, that large number of these countries who are maybe at the using manufacturing as the engine of growth, they actually were producing the machines which also make machines, right? So their differentiation was very high, correct? So you cannot easily replicate what they were actually doing, right? So these questions are actually significant when we talk about manufacturing, and this data is 2018 data, and it actually tells you how each country is actually contributing to the global manufacturing, right? So China maybe about a quarter of, more than a quarter of the global manufacturing. And for historical reason, let me just put that at the beginning of the Industrial Revolution, China was contributing about 33% of the global manufacturing, and India was contributing about 25%. Right. So China still has, maybe for whatever reasons, the China still is closer to that number, but India has come down drastically, right. So from 25%, they are now at about 3%, correct. And you look at the countries which I was talking in great divergence, look at US, you look at Japan, you look at Germany, you look at Italy, France, UK. So most of the countries who are actually, you can say, have leveraged the Industrial Revolution well, they are actually part of this, whatever, the top 10 list, correct. So China in fact have significantly gained lot of outsourcing, right. So we'll talk about that when we talk about supply chains, right. Lot of cost arbitrage. US traditionally is a high manufacturing country, but their global contribution is about 16%, right. So this data I think will give you an idea that how we actually can, so whether it is possible for India to start hitting these numbers, right, and whether the technology will allow us to do that, correct. So, so this gives you the macro picture, right. Now, I will continue my discussion, but now I think I will go, so we are talking background of the future, and now I will start building the manufacturing paradigms, right. So, manufacturing in pre-industrial revolution, right, and my story will start with a very interesting poem by Kipling, right. In fact, Kipling is known more for the Jungle Book, right. So you might have seen that character of Mowgli. So if you just look at this particular uh, uh, poem by Kipling, it says, "Gold is the mistress, silver for the maid, copper for the craftsman." But the last line is significant, that cold iron is the master of them all. Right, correct. And in fact, iron comes as at the center of all this manufacturing revolution, maybe iron and steel, right. And I think now we start building the case how this advances in maybe iron refining and steel manufacturing has actually brought those thoughts of which actually takes us to the goals of manufacturing, right. So, yeah, so I'll just start building that case, right. So a lot of you would have heard about a simple process of smelting. I think in our high school books we talk about smelting, right. It is a reduction process to make iron from iron oxide, right. But traditionally this process, maybe if I go to 5,000 years back, this process even existed at that time, but it was not used to make iron, it was actually used to make copper and zinc, right. And so this process continued for copper and zinc, and then there were some modifications which was actually done in about 1200 BC, where this process was actually modified. In fact, the modification came so in terms of keeping the furnace sufficiently hot so that you actually can use smelting to make iron, right. And then what actually happened, right. So the cost of iron refining substantially reduced, right, because of this. I can now call the contribution of technology, right. So let my technology be smelting, and that actually has significantly reduced the cost of iron refining. In fact, during that time, so this is all the historical data. I have taken it from a source where all these numbers have been normalized. This led to decrease of prices of iron by 97%. Right. Correct. and steel was also discovered around the same time. So this process was in, if you know, Mesopotamia, right, which may be closer to modern Iraq, right. And so steel was also discovered around the same time, and steel is nothing. Means I'm pretty sure that all of you know that steel would have you can get different kind of a steel, but when we talk about steel, we are talking about as an alloy, right? So the Chinese were pioneer in that, and they were in fact using the blast furnaces. So if you go to a modern steel plant, we still talk about blast furnaces, right, to make steel, right? They are still the pioneers. In fact, I think if I go by the numbers, China is the largest producer of steel, about 800 million tons. India is the second highest, but India is about 10% of that number, correct? Right. And Chinese were using these blast furnaces to make steel way back about more than 2000 years ago. So what it actually signifies, because when I talk about blast furnace, I am talking about a batch process, right? So I will discuss those things as we go deeper into that, right? And these blast furnaces are normally large in scale, right? So it means that the Chinese got some idea about that if you scale the production up, the cost would actually come down, right? So we are actually now talking about the economies of scale, which we formally will see as we go more into the course, right? But for time being, just believe me that Chinese were using the blast furnaces, right? And they actually have some idea about how the scale and the costs are actually related, correct? Right. And I think that whatever the wisdom, they in fact they may be really the making the best steel till the advent of industrial revolution, right? So for time being, uh, we stop here, right? So we will continue our discussion on manufacturing in pre-industrial revolution, and we are going to see different manufacturing paradigms as well as different kind of manufacturing processes, and how these processes, these manufacturing paradigms are actually linked to those four initial goals, right? So I'll continue this in the next session. Okay, thank you.